Whereas RAG gives you one way to give additional information to a large language model, there's another technique called fine-tuning, which is another way to give it more information. In particular, if you have context that is bigger, that can fit into the input length or the input context window length of the LM, then fine-tuning gives you another way to get an LM to absorb this information. And fine-tuning also turns out to be useful for getting the LM to output text in a certain given style. But its actual implementation is a bit harder than RAG. Let's take a look. Let's say you have an LM trained the way that we had described previously, with sentence found on the internet like, my favorite food is a bagel with cream cheese. Then it may have learned from hundreds of billions of words, or maybe more than 1 trillion words, to predict the next word like this. An LM like this will have learned to generate text that sounds like what's on the internet. And this process of training a large language model on a lot of data is often called pre-training. Now, let's say I want to modify the LM to have a relentlessly positive and optimistic attitude about everything. There's a technique called fine-tuning that we can use to cause the LM to do a little bit more learning, to change its outputs to be, in this example, much more positive and optimistic. To fine-tune the LM, we would come up with a set of sentences or a set of text that takes on a positive, optimistic attitude, such as, what a wonderful chocolate cake, or the novel was thrilling. Given text like this, you can then create an additional data set using what a wonderful chocolate cake you would have, given what. Next word, it will try to predict A, what A. Next word is wonderful, what a wonderful chocolate, and so on. And it turns out that if you take an LM that has been pre-trained on hundreds of billions of words and fine-tune it on just an additional, say, 10,000 words or more, could be 100,000 words if you have more data, or even 1,000,000 words if you have even more data, fine-tuning to this relatively modest-sized data set can shift the outputs of your LM to take on this positive, optimistic attitude. Now, maybe shifting an LM to have a relentlessly positive attitude isn't that helpful in application, but fine-tuning is used in many real applications. One class of applications that fine-tuning is used for is when the task isn't easy to define in a prompt. For example, if you want to use an LM to summarize customer service calls, a generic LM may look at a call like this and summarize it to say the customer tells the agent about a problem with a monitor. But if you run a customer call center, you might want it to generate specifics about what the conversation was about. It was about the MK4127KX reported broken by customer 5402 and so on. And if you create a data set with maybe just hundreds of examples of human expert written summaries and have a large language model that's learned from hundreds of billions of words on the internet, so it's learned a lot of general knowledge on the internet, but if you additionally fine-tune it on maybe just hundreds of carefully handwritten summaries of this specific style, then that would shift the LLM's ability to write summaries in the style that you want. And the specific style of summary is actually not that easy to define in a text prompt. Maybe you could do it, but fine-tuning would just be a very precise way to tell the LM what summaries you want. Another example of when a task isn't easy to define in a prompt is if you want to mimic a specific writing or speaking style. So Tommy Nelson, who's been working with me on this course, actually tried, kind of just for fun, to get an LM to sound like me. But it turns out that the way most individuals sound is not that easy to describe in a prompt. I mean, how would you give someone clear instructions to sound like me? So if you were to prompt a general purpose LM and ask it to sound like me, you get text like this, which I don't think it sounds that much like me. But if we were to take a lot of transcripts of the way I actually talk and have an LM be fine-tuned to train it to really sound exactly like me by learning on my actual words, then asking it to write something that sounds like me results in text like this, which, I don't know, this sounds more like how I would talk. But because mimicking a specific writing or speaking style is very difficult to do via prompting, because it's just difficult to describe a specific person's style by writing text instructions, fine-tuning turns out to be a more effective way to get an LM to speak in a certain style. And if you're building an artificial character, maybe a cartoon character, fine-tuning could also be a way to get an LM to speak in a certain style. Other than tasks that aren't easy to define in a prompt, a second broad class of applications of fine-tuning is to help the LM gain a domain of knowledge. For example, if you want an LM to be able to read and process medical notes, this is what a medical note written about a patient by a doctor might look like. And this is really not normal English. PT is patient, CO complaining of, SOB shortness of breath, DOE dyspnea on exertion, PE, this is the results of the physical examination, and so on. Treatment is to follow up with the primary care physician, STAT, chest x-ray containing treatment as needed on oxygen. But this is really not normal English. And if you were to take an LM trained on normal English, it wouldn't be very good at processing text like this. So if you were to fine-tune an LM on a collection of medical records, then the LM could get much better at absorbing this body of knowledge about what medical notes sound like. And you could then use that to build other applications on top of it to better understand medical records. Or legal documents. Here's a piece of legalese, kind of written by lawyers for lawyers, that's really difficult for non-lawyers to read. Licensee grants the licensee per section 2A3 a non-exclusive right, and so on, within 15 days hereof. I don't know about you, I do not use the word hereof in my ordinary day-to-day speech, but this is what legal documents sound like. And if you want your LM to gain a body of knowledge about how to read and understand legal documents, then taking LM and fine-tuning it to legal documents would help it to gain that body of knowledge. And similarly, financial documents too. Fine-tuning an LM on a large set of financial documents would help it to better gain that body of knowledge about finance and make it better at applications involving processing documents that look like this. Finally, another reason to fine-tune an LM is to get a smaller model to perform a task that may previously have required a larger model. We'll discuss later this week some of the pros and cons of choosing a larger versus a smaller model. But for some LM applications that need a lot of knowledge or need complex reasoning, you might use a relatively large model, say with over 100 billion parameters. But if we were to use a model like that, such a model may have relatively high latency, meaning after you prompt it, you might need to wait a while to get back a response. And if you were deploying this on your own computers, it could be quite costly. And even though we said in an earlier video that these models aren't that expensive, maybe you want it to be even cheaper. And that's because a 100 billion parameter model may take specialized computers, such as a GPU server or other really fast computers to run. You'd probably have a hard time running such a large model on a normal laptop or PC, and certainly not on a smartphone today. But if you can get your application to work on a much smaller model, say 1 billion parameters, then that's the range of model size that it would run much more easily on a laptop or a PC or on a mobile phone. So for example, if what you want is to classify restaurant reviews as positive or negative sentiment, this is a simple enough task that you probably don't need a 100 or 200 billion parameter model to run, but maybe a 1 billion parameter model would be just fine, maybe even smaller, frankly. But these smaller models aren't as smart or they aren't as good as the really large models, which is why if you were to take a small model and then fine-tune it on a dataset like the one shown here, not just 3 examples, but maybe a few hundred or maybe 1,000 examples if you have that much data, then you can get a small model, say 1 billion parameters, to do really well on a task like this. So to summarize, fine-tuning gives you another technique in addition to RAG to help improve the capabilities of an LM. You might use it for tasks that are hard to specify in a prompt, such as if you wanted to output text in a certain style, or if you want the LLM to gain a body of knowledge, such as about medical notes, or if you want to get a smaller and cheaper to run LLM to do a task that might otherwise have required a larger LLM. It turns out that RAG and fine-tuning are both relatively cheap to implement. RAG just is modifications of your prompt, and fine-tuning, you might be able to get started with tens of dollars or maybe low hundreds of dollars, depending on how much data you want to fine-tune on. There's another technique, pre-training your own model, that turns out to be very expensive. And today, almost no one other than reasonably large companies, usually tech companies, are attempting this. But for completeness, let's take a look at the next video at what pre-training involves.